So let me show you one way you can interact with this drone with code. So I've already connected to this drone, and now what I want to do is call this take control method, drone.takeControl. And I'm about to do this, so as I do, pay attention to this little button here that says manual. As you can see, taking control changes the command mode to guided. Next, I can call drone.arm, and before I do, pay attention to these rotors, because a call to drone.arm causes them to start spinning. And now we're almost ready to do the really fun stuff, which involves actually flying the drone. So let's take off to an altitude of 5 meters. Sure enough, the drone flies up as expected. I can use this command position method to actually set a target position, and the drone should fly there. And now let me fly back to where I started. Alright, this is starting to make commanding the drone look pretty easy, and in fact it is pretty easy. Now remember, the final project for this lesson involves making a drone fly in a square. Well, given this command position interface, it seems like it should be pretty easy to do that. And in fact, I've done it down here. Here we define the coordinates of a square, or the coordinates of the corners of a square, I should say. And if we just loop through those corners, then we can just do a drone.commandPosition star corner. Let's just run this to see if it works as expected. Sure enough, it flies right. Then it flies back. Now we're at 1010. Then it flies left to 010, and back forwards to where it began at 00. So great, problem solved. Final project over, on to the next lesson, right? Not quite, because there's actually a problem with structuring our drone code this way. And to highlight what that problem really is, I'm going to run this cell again, and as I do, I want you to not focus over here on the actual simulator, but over here on the code that's executing. So let me run the cell. And here you see this asterisk up here. And this asterisk is Jupyter Notebook's way of saying this cell is currently executing code. Now, the reason why I'm calling your attention to the fact that the cell is executing code is because that means this code is all blocking code. This drone is going to go in a square trajectory before it does anything else, which is fine in a nice simulated environment. But what about in the unpredictable, unknowable real world? What if, when I executed this cell, shortly after, another drone flew in the way of ours, or something else happened? The fact is, there's all sorts of unpredictable obstacles that could occur. And when these things happen, our drone needs to be able to respond dynamically. And using this linear, sequential style of programming just isn't going to cut it. We're going to need a different way of thinking about our logic. And that different way is called event-driven programming.